Hello there, fellow math enthusiasts. Mrs. Delzati here. Today we're taking a look at a Unit 2 recap. We're looking again at exploring linear relationships. So this unit focused a lot on independent and dependent situations. Let's take a look at number 1. Number 1 wants us to identify the independent and the dependent variable of the situation. The cost of the roses depends on the number of roses ordered. Okay? Depends on. The cost depends on the number of roses. Therefore, the dependent variable is our cost of the roses. It depends on the independent variable, which is our number of roses ordered. Looking at number 2, I want to write a function rule that models each of the situations. Part A says Cammie has $1,500 and is spending $35 each week. So if we talk about money, she is originally starting with $1,500. And if she's spending $35 each week, spending means that it's going down. We are subtracting $35 each week. So 1,500 minus 35W. Part B, Terrific T-Shirts charges a $40 service fee plus $4 per shirt. So let's talk about our cost here. Originally, our starting point is at $40, and then they go ahead, they charge $4 for every T-shirt. Okay, C is equal to 40 plus 4T. And then part C, a regular pizza costs $10, with each additional topping costing $1.50. So let's we'll say P for pizza, and we'll see that it's a $10 original cost, and each topping is going to be $1.50. So we add $1.50 times T. Let's take a look at number 3. We've got Ben's Flower Emporium, and it gives us the equation C is equal to 10 plus $1.50 R. So the cost is equal to 10 plus $1.50 times each rose. Or Carly's Carnation Palace, where C is equal to 5 plus 3R. And I want to know, if we order 12 flowers, which store is better to buy from and why? Well, let's go ahead and let's evaluate. We'll say R is going to be equal to 12. That's the number of roses or flowers that we're buying. And if we're talking about Ben's here, we can say 10, or C is equal to 10 plus $1.50 times 12. If I go ahead, I punch that into my calculator all at once, 10 plus $1.50 times 12 is going to give me $28. Now, if I want to go ahead and talk about Carly's, well, Carly's, our cost function, it's $5 originally plus $3 for each flower. So 3 times 12, which means I'm doing 5 plus 36, which is going to go ahead and give me $41. So clearly we can go ahead, we can see that Ben's is going to be cheaper. And we can say that 41 minus 28 is $13. So Ben's is cheaper by $13. And that's why it's better to go ahead and buy from that store. All right, moving right along, let's take a look at number 4. Number 4 says Jason is ordering a bouquet for his girlfriend for her birthday. There is a base fee of $6 for a bouquet with an additional $1.50 per rose he adds in. Write a function rule that models this situation. Identify the slope and the Y-intercept. So we have cost of the base fee is $6, an additional fee of $1.50 per rose. This 6, this is my starting point. The $1.50 per rose, this is my slope. Okay, that is my rate of change. That is $1.50 per rose, and then if we add on that starting point, that is plus 6. So the slope, the one that's attached to the variable, is a 1.5, and then my y-intercept, my starting point, is 0, 6. Let's go ahead, let's flip it on over. And now we're going to take a look at our table. And what I want us to do here is I want us to be able to identify the slope and the y-intercept. When it's in table format, it's nice just to be able to do our jumps. So to go from 35 to 40, we added 5. To go from -1 to 0, we added 1. And keep in mind that when we are doing our slope, it's the change in y over the change in x. So 5 over 1 means our slope is going to be 5. And then for my y-intercept, well, the y-intercept is where x is going to be equal to 0. If I look right here, x is at 0 and y is at 40. That y-intercept, again, is always a coordinate. All right, look at number 6. Now we're looking at a graph, and I want to identify the slope. I see that the line is going down, which means I know that the slope is going to be negative. So I can choose 2 points. I'm going to choose this first one and this second one, and I'm going to see that I have to count down 1 and over 3, which means that my slope is going to be -1/3. Now, the y-intercept is where the graph goes ahead and crosses that y-axis. If I'm looking here, it's at the 6. And again, we always write the y-intercept as a coordinate. It is 0, 6. Now, moving right along, number 7, I want to be able to find the slope of the line that passes through these pairs of points. Our slope formula. I'm going to write that down again for you. y2 minus y1 over x2 minus x1. We do the change in y's over the change in x's. So I'm going to label these x1, y1 and x2, y2. And to find the slope, I'll say 15 minus a -3, y2 minus y1 over 4 minus 2. Well, 15 minus a -3 gives me 18 over 2 means that my slope is going to be 9. Let's try B. Here is x1, y1. Here is x2, y2. And to find that slope, we'll do y2 minus y1. -2 minus 5 over 8 minus 2, x2 minus x1. Well, -2 minus 5 is -7. 8 minus 2 is 6. -7 over 6 does not reduce, so I can leave my answer just like that. All right, part 8, I want to draw a line that represents the following slopes. If the slope is positive, as we move from left to right, the slope goes up. If it is negative, as we go from left to right, it goes down. If the slope is 0, there is no vertical change. It is a horizontal line. And if the line is undefined, the slope is undefined, it's going to be a vertical line. Now, which type of slope above represents when the person is stopped? That means that their distance is not increasing or decreasing. Well, that's going to be a horizontal line. That's when the slope is 0. So this was a quick recap of Unit 2. Del Zadi is done for today. I will see you in class.